Okay, today is day 8 of chapter 4. We are going to be graphing polynomials. So the graph of a polynomial with degree of 2 or higher is an unbroken curve. The graph of a polynomial function of degree n has at most n minus 1 turning points. Excluded regions are the spaces where the graph cannot pass. Even multiplicity of a 0. So that would mean that the x-intercept is either going to bounce or it's going to be tangent. So it bounces or is tangent. And then if a 0 has an odd multiplicity, the x-intercept is going to cross over the axis. Okay, so if our graph looks something like this, okay, then right here, we would have 2 turning points. That's what we're referring to as turning points. But if our graph looks something like this, so if it was like a cubic, this has no turning points. So it's just going from negative to positive. It's not going, like in our first example, it's not going positive to positive again. It's not turning. This is just going negative to positive. So it's just increasing. So no turning point. Okay. So let's just get to our examples. We are going to determine the x and y intercepts and then specify the behavior at the x-intercepts, and then last we are going to graph. So in this first one, we have y equals x cubed minus 5x squared minus x plus 5. So right away, I know that my y-intercept is at 5, 0, 5. Okay, but to solve this one, we are actually going to factor by grouping. So I'm going to have y equals x squared, x minus 5, and then minus 1, x minus 5. Okay, so remember when you factor by grouping, we want to have the exact same binomial twice. Okay, so then I can just write this as y equals x squared minus 1, x minus 5, which then will be x plus 1, x minus 1, and then x minus 5. Okay, and these are all to the first degree. And that's important because when we talk about multiplicity of the zeros, we need to know if it's going to be an even or odd multiplicity. So our x-intercepts is going to be 1, 0, negative 1, 0, and 5, 0. Okay, I switched these two. Right? So each of those have an odd multiplicity. They all just have multiplicity of 1. So at each of these x-intercepts, we are going to cross the axis. Okay? And then I know that my y-intercept is at 0, 5. Okay, so the next thing I'm going to do is go ahead and plot the points that I have. So I have my y-intercept at 0, 5. And then I have my x-intercepts at negative 1, 0, positive 1, 0, and then 5, 0. Okay, now I need to determine how my graph is shaped. So is it coming from the negative direction or the positive direction? So we are going to test some values. So we have our 3 x-intercepts. Okay, so we've got negative 1, 1, and 5. So I need to test some values that are going to be less than negative 1. So I'm going to pick negative 2. Then in between negative 1 and 1, so I'm going to pick 0. In between 1 and 5, I'm going to pick 2. And then greater than 5, so I'm going to pick 6. Okay, so what we're going to do is take those values that I chose and substitute it into our original equation. So y equals x cubed minus 5x squared minus x plus 5. So you should take out your calculator, and let's go ahead and test these values. So if I put negative 2 and store that in for x, we get negative 21. So I get a negative number. If I substitute 0 in, then I'm going to end up with positive 5. So that's a positive number. If I substitute positive 2 into that original equation, I get negative 9. So that's a negative number. And then if I substitute 6 in for x, I will end up with positive 35. So again, a positive number. Okay, so that's going to help us determine which direction our graph is going. So when we are approaching negative 1, 0, we are approaching that from the negative side of the x-axis. So I'm going to be coming down here. Okay, then I know that I'm crossing the axis, so I'm going to go up to positive 5, 0, positive 5. Okay, then I have to get back down to positive 1, 0. Again, I have to cross the x-axis. Then I need to turn around, and at positive 5, 0, I'm increasing into the positive direction. Okay, now this is just an estimate of our graph. We don't know, like, so for example, where I'm highlighting in yellow, we don't know where exactly that turns around. If you really want to know, you could take a value, you could pick like positive 3, plug that in and see where it's actually going to be turning around. But for right now, we're just trying to figure out the general picture of this graph. Okay, so that would be the graph of this polynomial function. Going to number 2, we have y equals x minus 1 squared, x minus 4 squared. So I know my x-intercepts. My x-intercepts are going to be at 1, 0 and at positive 4, 0. Okay, and my multiplicity is 2. It's even for both of them. So they are tangent, my x-intercepts. So that means when I graph this function, we are going to be bouncing at those x-intercepts. So we will not be crossing the x-axis. We're going to be having a turning point there. Okay, then to find my y-intercept, I'm going to substitute 0 in for x. So y equals 0 minus 1 squared, and then 0 minus 4 squared. So I end up getting y equals 1 times 16. So y equals 16. So my y-intercept is 0, 16. Okay, let's go ahead and label our axes. So for my y-axis, I'm going to increase by 2. Okay, so my y-intercept will be right here at 0, 16. Then for my x-axis, I'm just going to increase by 1 each time. So I would have my x-intercept at 1, 0, and then at 4, 0. So again, we're going to have to test some values. So I've got my x-intercept at 1 and at 4. So I'm going to test a number that's smaller than 1, so I'm going to pick 0. Then in between 1 and 4, so I'm going to choose 2. And then larger than 4, so I will pick 5. Again, you can pick different values. When we substitute 0 back into our original equation, we will end up getting 16, so that's a positive number. Let's go ahead and store 2 in for x and substitute that into our original equation. We end up getting 4, so that is positive. And then if you substitute 5 in for x, we get 16, which again is a positive number. So when we go ahead and sketch this graph, when we approach our y-intercept, we're going to be coming from the positive direction because at 0, we're coming from positive. Okay, so I'm going to be coming down here. Then when I reach my first x-intercept at 1, 0, it's tangent, so I'm going to make a turn here. Then I'm going to be increasing for a little bit. Then I have to turn around again to get to my x-intercept at 4, 0. But then I have to bounce back up into the positive direction. Again, your graph may look a little bit different. My graphs are always horrible. Anyone in my class knows I'm not the best sketch artist. So I hope yours looks better than mine. But again, you can test more values if you want your graph to be a little bit more accurate, but we're just trying to get the general direction of our functions. Okay, number 3 is our last example for today. So we have y is equal to x plus 1 squared times x minus 1 times x minus 3. So let's go ahead and start with our x-intercepts. We are going to have an x-intercept at negative 1, 0, positive 1, 0, and positive 3, 0. Okay, we are going to look at the power for each of those to find out our multiplicity. So for our first one, we have multiplicity of 2. That is even, so I know that at negative 1, 0, it is going to be tangent. At my x-intercept 1, 0, that multiplicity is odd, so it is going to bounce or cross the x-axis. And same with 3, 0, we are going to be crossing the x-axis. Okay, to find our y-intercept, we are going to be substituting 0 in for x. So we will end up with positive 3. So my y-intercept is 0, 3. Okay, so I'm going ahead and plot those points. So I'm at 0, 3, then negative 1, 0, positive 1, 0, and positive 3, 0. Okay, our next step is going to be to test some points. So we have negative 1, positive 1, positive 3. So I'm going to test negative 2, 0, 2, and 5. So go ahead and take a second and substitute those values in for x and determine if you are going to be on the positive or negative side of the x-axis. Okay, so if you tested out your values, you should end up with your table looking like this. So positive, positive, negative, positive. So when we are approaching our first x-intercept at 1, 0, we are coming from the positive direction. And then that multiplicity was 2, so it is tangent. So I am going to bounce back up to get to my y-intercept. I'm going to curve back down to get to 1, 0. At 1, 0, the multiplicity was an odd number, so I'm actually going to dip below the x-axis and then curve back around to my last x-intercept at 3, 0, which again had an odd multiplicity, so I'm going to cross the axis into the positive direction. Okay, so again, hopefully your graph looks a little bit nicer than mine, but we are going from the positive direction and making a few turns.